The title of my project describes what I am doing in my experiment: experimental evaluation of household fabrics to determine aerosol filtration performance for development of an improved COVID-19 mask. The purpose of my experimental project is to protect people from COVID-19 through a better mask by testing household fabrics to see how many aerosols and particles each fabric can stop. If out of those fabrics there are a couple of fabrics with the best protection, I will try to combine those fabrics to form a mask, and then compare my mask fabric to an N95 mask fabric. I chose this project because I want people to be protected. For now, with yet no vaccine, the only other way to be protected is through masks, and our masks need to have better performance. The first step is to construct the test apparatus, and then we can conduct the experiment. Take out aerosol monitors, add batteries, and do zero calibration.
From here, go all the way down. Is it done? Here we go.
Then cut a 10 centimeter by 10 centimeter extra piece from the fabric to use as a filter. Put the filter number on each filter fabric in Sharpie in the corner. And now we are going to start our experiment. I'm going to be testing my samples today. I'm going to be testing fabric number 3. So, first thing we need to do is get the fabric. We put this in a smaller one, so then it'll be able to fit the filter holder. So we can put in wherever we like. You hold up front, and then you let this section in. And now we're gonna attach it to here. And we're holding the back here. And putting very little space in between here. See, as I said before, in a couple of videos ago, this is the before. This will testing the before, and this will be testing the after filter. So first, 1 and 2. And we will see all the numbers start getting higher and higher. But the thing is, it's not going to get high enough, and we want to reach it just to its limit. So you do a small scoop. The purpose of this experiment was achieved. However, my hypothesis that the black felt sheet would stop more aerosols and particulates than other household fabrics was incorrect. Filter number 25, the green felt sheet, had a filter efficiency of 87.8% of particulate matter lower than 1 micron in size, which is also called PM1, while the PM1 filter efficiency for filter number 23 and number 24, lightweight corduroy, was 94.4%. There were 2 filters that achieved the best results. They were a triple layer using filters number 27, pure silk, with number 26, 100% lightweight jean in the middle, plus number 27, pure silk, and a triple layer filter using filters number 27, pure silk, in the middle number 25, the green felt sheet, 100% polyester, and at the end number 27, again, pure silk. These 2 filter combinations had a total filter efficiency of 99.4%. This compares to the N95 mask, which had a total filter efficiency of 99.998%. It was also very surprising that the silk had such a high filter efficiency for such a thin piece of fabric. The PM1 filter efficiency was 84.4%. Using this information is greatly needed today in this world. The results of my experiment will be useful to almost everyone in the world. This can include teachers, children in school, people shopping for groceries, workers in factories, and people doing many other activities. Healthcare staff would not use this at work because the government would supply them with N95 masks. But when not working, the results of this experiment would be useful to healthcare workers in their daily personal activities. A lot of people cannot afford a manufactured mask. This experiment will help ensure that they will have an efficient mask. I had some difficulties that occurred when testing the fabric filters. When I tested the fabric filters and shook the plastic container briskly forward to back in a circular motion, the meter on the dust track would rise. But when the dust track had a maximum of 150 milligrams per meters cubed, when it reached it, it would stop testing the particulate matter and completely shut down the test run. There are multiple times when the meter reached 150 milligrams per meters cubed, the whole device would stop and not go any further. Then the fabric sample had to be tested again. Since this happened very frequently, I called this the 150 bomb. My future research would include sending a sample of my fabrics with the best results to a professional lab. The lab would test this to have a more accurate measurement of the filter efficiency. Having this information will also help determine how well my experiment works at measuring the true filter efficiency. I have used a scientific method in my entire project. I have asked a question on how to make a better mask using household materials and compared with an N95 mask. I created a hypothesis, experimented on 30 household fabric filters and more than 5 combinations of doublets and triplets, and found 2 combinations that both had a total filter efficiency of 99.4%. This is a very efficient household mask compared to the N95 mask, which had a total filter efficiency of 99.998. This represents a total filter efficiency difference of 0.598%.